Hey guys, welcome to the 2016 Calculus Paper Level 2 from NZQA. So a recommendation for you guys with this particular video is that every time a question comes up, just pause the question at the beginning, try and do the question by yourself, and then listen to my answers and see how far you've actually gotten into your question. All right, I'll also, in each question, I'll actually tell you guys which part has achieved merit and excellence and so forth. Okay, so let's get started with question one. All right, so for question one, we've got this function that's been given to us, and we've been asked to find the gradient where x is equal to 2. So what I'm going to do is I always like doing this. I like writing my function down first. So we got 4x cubed minus 7x squared plus 2x minus 4. So differentiating this function, f dash of x will be 12x squared minus 14x plus 2. So at this point, I'm trying to look for the gradient when x is equal to 2. So I'm actually looking for f dash of 2. So what I have is 12 multiplied by 2 squared minus 14 times 2. And of course, I've got plus 2. So basically, I've got the gradient is equal to 22. Okay, so that's question one. Question one is an achieved question, folks. So you obviously need to find the derivative and also need to work out the gradient as well. Okay, let's look at question 1b. So what we have is the line y equals x plus 3.25 is a tangent to the graph of this particular function. Use calculus to show that the line is tangent to the curve and that the point where this tangent touches the curve is 0.5, 3.75. So what we're going to do is a couple of things you need to realize first. So we know that the line that's tangent to the graph, this particular line, the gradient for this line is equal to 1, m equals to 1. Okay. Now the next thing is we need to work out the gradient function f dash of x and actually find out when this gradient is equal to 1, and that'll give us the x value, which should give us this thing here. And then when we substitute the x value back into f of x, we should get the y value. Okay, so first thing I'm going to do is I'm going to differentiate the function. So I've got f of x equals 3x squared minus 2x plus 4. Differentiating it, I get 6x minus 2. Now, because the tangent has a gradient of 1, I know that the gradient has to equal 1. But I need to figure out for what x value the gradient is equal to 1. So, because I know that f dash of x is equal to 1, I can actually say 1 equals 6x minus 2. And rearranging this, I'm going to get 1 plus 2 equals 6x, 3 equals to 6x, and then x equals to 3 over 6, which equals to 0.5. And as you can see, we've actually worked out the x value of this point. So now to work out the y value, we need to find out f dash, it's not f dash, sorry, f of 0.5. So we've got the f of x function, which is 3x squared minus 2x plus 4. So we're trying to find f of 0.5. So that would be 3 multiplied by 0.5 squared minus 2 times 0.5 plus 4. And when you simplify this, you're going to get 3.75 as the point, as the y value. Therefore, you've shown that the point where it actually touches is 0.5, 3.75. Now, you don't actually need to use the f of x. You could have also used the equation of the line itself. Either, you're still going to get 3.75. So to get to merit, you need obviously to show how you got the point. So you could actually use this method here. And for achieved, you need to find derivative. So you need this part, derivative function, and also show that you've actually used the gradient equals to the derivative function. That's what you're getting for achieved. All right, let's go to question 1c. So in 1c, we've got the function f of x has a minimum turning point where x equals to 1. What are the coordinates of the maximum turning point? All right, so what we're going to do is we're going to differentiate the equation first. So because we've got f of x equals 2x cubed plus kx squared plus 5, when we differentiate this, f dash of x equals to 6x squared plus 2kx. Now it tells you that it has a minimum turning point when x equals to 1, which means we can say f dash of 1 equals to 0. Remember that if there's a turning point happening, turning point happens when gradient is equal to 0. So because they say when x equals to 1 there's a minimum turning point, we can say f dash of 1 equals to 0. So I'm going to take this f dash of 1 and substitute it in this equation, which is 6x squared plus 2kx. Now because I know f dash of 1 equals to 0, I'm going to replace the left hand side with 0, and because x is equal to 1, I'm going to get 6 times 1 squared plus 2 times k times positive 1. So I've got 0 equals 6 plus 2k. Rearranging this, I'm going to get negative 2k equals to 6, and k equals 6 divided by negative 2, which equals to negative 3. So that's the first step, and for this part, getting up to here will get you an achieved. So in terms of carrying on to actually get this into a merit, what we do know now is that the gradient function. We now know that the gradient function f dash of x can be written as 6x squared plus 2 multiplied by negative 3, because we figured out k equals to negative 3 x, which means f dash of x can be written as 6x squared minus 6x. So once again, turning point happens when f dash of x is equal to 0. So what we can say is 0 equals 6x squared minus 6x. Factorizing this, I'm going to get 6x multiplied by x minus 1. And from here, I can say, therefore, x is equal to 0 or x is equal to positive 1. Now, it's asking you to find the coordinates of the maximum turning point. Obviously, when x equals to 1, that's the minimum turning point, because that's according to the question there. So if this is the minimum one, x equal to 0 has to be the maximum one. But the question is actually asking what are the coordinates. So you actually need the y value when x equals to 0. So you got to find f of 0. So you've got 2 multiplied by 0 cubed plus k, which we know as negative 3, 0 squared plus 5. And so we can find out that f of 0 equals to 5. So the coordinates of the maximum turning point, so we just say maximum turning point equals 0 and 5. And folks, that's what's going to get you a merit grade for this particular question. Okay, let's go to question 1D. Okay, so with 1D, the equation of the function y equals f of x, blah, 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 has a gradient function of the form, thus 2x minus a. The point 34 is the turning point in the graph of the function. Find the equation of the function. So obviously there's an integration question. Now what we're going to do is we've got f dash of x equals 2x minus a. So we know that f of x can be written as integral of 2x minus a dx. So f of x would then be 2x, I'm just going to do this quickly, guys. So we're going to get x squared over 2 minus ax plus c. So what we have is f of x equals x squared minus ax plus c. Now the problem is there's actually two unknowns in this case. I've got a that's unknown and c that's unknown. It would help if I'd actually figured one of these beforehand. So the best way to do it is going back to the question. You can see that the point 34 is the turning point. Now, if 34 is a turning point, then the gradient when x equals to 3 is 0. So what we can say is f dash of 3 equals to 0. But if you have a look at it, we've already got the gradient function. The gradient function is f dash of x equals 2x minus a. And because we know that f dash of 3 equals to 0, we can say 0 equals 2 times 3 minus a. So we're going to get 0 equals 6 minus a, rearranging it, we're going to get a is equal to 6. So now that we've figured out a, we can go back to f of x and rewrite it as x squared minus 6x plus c. Now what we do know is that the turning point is 3, 4. So in other words, we can say that f of 3 equals positive 4. So substituting f of 3 and 4 into the original equation, we're going to get 4 is equal to 3 squared minus 6 times 3 plus c. So simplifying this, we got 4 equals 9 minus 18 plus c. 4 equals negative 9 plus c, and c equals 4 plus 9, so c equals 13. So the equation of the function is going to be y equals x squared minus 6x plus 13. And so guys, to get the final answer, you are looking at an excellence grade here. Antiderivative find, so getting up to this part here, where you're putting it with just C, that gets you a merit. And I think you've got to do this part first to actually get an achieved. Okay, that's question 1D. Let's go to question 1E. Right, so with question 1E, it says find the local minimum value of the function, this particular function, justify your answer. So the first thing you've got to do is, obviously you've got to expand this equation, differentiate it, equal to 0, find the points, and then figure out which one's maximum and minimum. So the first thing I'm going to do is I'm going to write this as f of x equals x cubed multiplied by x minus 4. So expanding this, I'm going to get x to the power of 4 minus 4x cubed. So from here, when I differentiate it, f dash of x is going to equal 4x cubed minus 12x squared. So what I could do at this point is I need to put the gradient equals to 0 to find out turning points. So turning points when m equals to 0, or f dash of x equals to 0. So I've got 0 equals 4x cubed minus 12x squared. Now guys, really be careful with this. Don't shift the 12x squared to the left hand side and then cancel the x's, because you will end up missing one of the x values. Always factorize. So in this case, I'm going to factorize this as 4x squared multiplied by x minus 3. And from here, I can say that 4x squared equals to 0, or x minus 3 equals to 0. So in my first one, x equals to 0, and my second turning point is when x equals to 3. So from this point, I'm actually going to show you guys two ways of actually doing this particular question. Now, it's asking you for the local minimum value of the function, right? So first thing you can do is you can actually find out what f of 0 is, and then find out what f of 3 is, and actually compare the y values and see which one is smaller. That'll be the local minimum value. So that's the first step I'm going to do. I'm going to find out f of 0. So with f of 0, I have 0 cubed multiplied by 0 minus 4. And straight away, f of 0 is 0. When I work out f of 3, I'm going to get 3 cubed multiplied by 3 minus 4. So I've got 27 multiplied by negative 1 equals negative 27. So at this point, you can actually talk about, you can justify this by saying that, well, since f of 3 has a y value of negative 27 and f of 0 has y value of 0, you can see that negative 27 is actually below 0. So that's why that's why this will become the local minimum. So that's one way of doing it. The second way you can do is double differentiate. So what we have is f dash of x equals 4x cubed minus 12x squared. When I double differentiate it, I'm going to get 12x squared minus 24x. And I need to substitute my values for 0 and 3. So f double dash of 0 equals 12 times 0 squared minus 24 times 0, which is going to be 0. So can't really give much information about it. But f double dash of 3 equals, will be 12 times 3 squared minus 24. So what we, 24 times 3. So what we have is 12 times 9, which is 108, minus 72, and you've got the answer of 36. So remember that when f double dash of x is greater than 0, we're looking at a local minimum point. Therefore, 3, negative 27 is local minimum point. Okay, so I think just getting up to here, guys, you're looking at a merit. The rest of the part, so you can do it method 1 to get excellence or method 2 to get excellence. And for achieved, I think just getting up to this part here will get you an achieved for this question. Okay, let's go to question 2. Okay, question 2. The diagram below shows the graph f of x. I think I forgot the other part of the question. The other part of the question was sketch. I think it was sketch f dash of x. So in this question, guys, you were actually given a second grid below in the exam paper, but I'm just going to use the original grid to kind of show you guys, so it just makes it a bit easy. So the way, look, I'll be honest, I hate sketching these graphs, but I wanted to give you guys a couple of really quick tips on how to actually do this. So for example, when I look at this graph, I know that this graph has, well, it's a cubic shape, all right, just generally a cubic shape. And when I differentiate this cubic, I'm going to get something like this, 3x squared. So when I differentiate this, I should get a parabola, which means if I look at this particular graph, it is a cubic. Because it's a cubic, I know that when the gradient function that I'm going to sketch will look more like a parabola. But the key important parts are actually finding out where your gradient are 0. So for example, in this case, the gradient is 0 there and 0 there, which means the gradient function has to go through that point there, and it has to go through that point there. That's the two important parts that you need to actually have with this gradient function. So in terms of how it can be drawn, as long as it goes through those 2 points, that's the key thing. And I think that's what you get for an achieved there. Hopefully that made sense, but yeah, it's just a lot of sketching, guys. That's what you have to do. All right, let's go to question 2b. Okay, so 2b, it says the line y equals ab is a tangent to the graph at the point 2, 3. Find the values of a and b. So basically, all you have to do is you've got to differentiate y value and find the tangent at that point, and then that will actually give you a and b. So we've got f of x equals 2x squared minus 3x plus 1. Differentiating this, we're going to get 4x minus 3. So first thing we need to find is the gradient at point 2. So we can say f dash of 2 equals 4 times 2 minus 3, which is 5. So we now know the gradient is 5, and it goes through the point 2, 3. So we can write the equation of the line. So we've got y minus y1 equals m times x minus x1. Our gradient is 5, and the point is 2, 3. So what we have is y minus 3 equals 5 times x minus 2. So expanding this out, we're going to get y minus 3 equals 5x minus 10, and y equals 5x minus 10 plus 3. Therefore, y is equal to 5x minus 7. So from here, we can say that the a value is equal to 5 and b value equals minus 7. And folks, that's going to get you a merit. Getting to the gradient of 5 will get you an achieved. Okay, question 2C. Function, once again, you're given a function. The gradient of the graph of the function at the point where x equals to 1 is 3. Find the value of a. So what we do know is f dash of 1 equals to 3. So we need to work out what f dash of x is and then figure out what a is. So what we have, we've got f of x equals 2 minus 4x plus 5x squared plus ax cubed, which means when we differentiate it, f dash of x, 2 becomes 0, negative 4x when you differentiate becomes negative 4, 5x squared becomes 10x, and of course you have plus 3ax squared. So at this point, guys, we know that f dash of 1 equals to 3. So we can actually put gradient is equal to 3 and substitute our x values as 1. So we get negative 4 plus 10 times 1 plus 3 times a times 1 squared. So we're going to get 3 equals negative 4 plus 10 plus 3a. Simplifying it, we've got 3 equals 6 plus 3a. 3 minus 6 equals 3a. Negative 3 equals 3a. Because we've got 3a equals to negative 3, a equals negative 3 divided by 3, and so we can say a is equal to negative 1. So that, ladies and gentlemen, gets you a merit. Derivative find and equate it to 3. So obviously you've got to get it to somewhere to this point to actually get an achieved. And that's question 2C. All right, let's have a look at question 2D. Okay, so what we have in this question is we got a chemical that is slowly leaking onto the floor. Blah, blah, blah. We got chemical spreads out in the point, lands in a shape modeled by a circle. So, all right, so it's going in a circle shape. At time t seconds, r is given by 0.1 t plus 2. Use calculus to find the rate of change of this area of the circle with respect to time when its radius is 10 centimeters. So what we're looking for is, we're actually looking for, different color pens. We're actually looking for dA of dt when r equals to 10. So the first thing we're going to do is we have area equals pi r squared. All right, but we need a and t, and I guess the thing to notice is that r is given by 0.1 t plus 2. So I need to replace this r with 0.1 t plus 2. So I'm going to get a equals to pi multiplied by 0.1 t plus 2 squared. So the next step is I need to expand this so that when I differentiate this function, I'll get dA dt. So a is equal to pi multiplied by 0.1 t plus 2. Because I've got to expand the brackets, guys, so 0.1 t plus 2 squared is going to be written like this. So a is equal to pi multiplied 0.1 t times 0.1 t will become 0.01 t squared plus 0.2 t plus another 0.2 t and plus 4. So area can be written as pi multiplied by 0.1 t squared plus 0.4 t plus 4. So from here, I can also say that a is equal to pi multiplied by 0.01 t squared plus pi multiplied by 0.4 t plus 4 pi. So now what I have is I've got the function for area in terms of pi. So I need to differentiate this to get dA dt. So dA dt will then become 2 times pi times 0.1 t plus 0.4 pi. And as for the 4 pi, well, when you differentiate it becomes 0. So dA dt can be written as 0.02 pi t plus 0.4 pi. So we have dA dt in terms of t, but the problem is radius is equal to 10. And we need to figure out at what time is the radius 10. So what we're going to do is we're going to do another little calculation here. So when radius is equal to 10, what is the time? So we've got 10 equals, but remember that radius can be modeled as 0.1 t plus 2 according to this thing here. So working with that top equation, I'm rearranging it. So 10 minus 2 will become 8. 8 is equal to 0.1 t, and t equals 8 divided by 0.1, which means t is equal to 80. Now that I have t, I can go back to my function of dA dt and substitute t as as 80. So it'll become 0.02 pi multiplied by 80 plus 0.4 pi. So in the end, what I have is 1.6 pi plus 0.4 pi, because 80 times 0.02 is 1.6. And simplifying this, 1.6 plus 0.4 pi will be 2 pi. And that's basically it. So at this point, I can leave it as 2 pi centimeters squared per second. And that's what the rate at which it's increasing by. Now you can write it as 6.28, guys. That's not a problem. But you're also fine leaving your answer as it is. So getting up to here is going to get you an excellence, relationship formed, and derivative found. And I think getting up to here, you'll be looking at a merit. Now, unfortunately, there's no achieved questions attached in this particular question, but that's how you do this question. Okay, let's go to question 2e. So question 2e, we've got a function that's defined by this lovely looking equation where a is a positive number. Find the range of values in terms of a for when the function is decreasing. So the first thing I'm going to do, as usual guys, every question is write f of x. So f of x is 3x cubed minus 4a squared x plus 5. So when I differentiate it, f dash of x will become 9x squared minus, be very careful with this, people start differentiating a squared, but a squared is a constant, so the only thing that gets differentiated is x, so you're left over with 4a squared. So that's f dash of x. Getting up to here gets you an achieved. Now, we need to work out when is this gradient actually, when the function is decreasing. For something to be decreasing, the gradient has to be less than 0. The gradient function, or the gradient itself, has to be less than 0 for it to be decreasing. So then we have 9x squared minus 4a squared has to be less than 0, or 9x squared has to be less than 4a squared. I can do one more. I can say x squared has to be less than 4a squared over 9. So getting it up to this point, I've kind of got it simple, but this is where I'm going to show you guys how to do this slightly different, because the most common mistake people do is they square root it. All right, they square root this value as 2a over 3, and they put x is less than 2a over 3 positive, and also x is less than negative 2a over 3. But I want to show you guys this particular case, all right? Now think about this. Take, for example, what an x squared graph would look like. Okay, an x squared graph looks like this. All right. Now, what we do know about a is a positive number. Okay. Let me just draw that graph in a slightly different color. So we've got an x squared graph that looks like this. Now, what we do know is a is a positive number, and we're trying to find out at what point in this parabola where y value is going to be less than 4a squared over 9. So I'm going to put 4a squared over 9 right here. Okay, which means if I was to draw a line 4a squared over 9, it's going to look like this. And if I say at what point is this parabola below that line, you can see that it's actually below the line somewhere. It's this part that's actually below the line. All right, so what we do need to do is we need to find out what this value is and what this value is. And we can do that because we know that x squared equals 4a squared over 9. And if we square root it, we're going to get plus or minus 2a over 3. So the positive 2a over 3 is here. The negative 2a over 3 is here. So if you look at this particular graph here, you can see that the function is decreasing. So for this, the final answer, the way you'd write it is decreasing function between negative 2a over 3 and positive 2a over 3. And this is how you write it. So, and that's basically it, guys. That's to actually get an excellence. But if you stuff up your intervals, if you stuff up how you write those intervals and you get up to this part here, you're looking at a merit value. But I think it's just understanding how decreasing function works, or understanding how particularly this equation actually works. And if you understand that, you generally can walk away with an excellence in this question. All right, let's go to question 3. Okay, so with question 3, we've got a gradient function. It passes through 1, 0, and we're trying to find the equation of the curve. So what we have is f dash of x equals 3x squared minus 5. So we're going to actually have to differentiate this. So we're going to, sorry, not differentiate, integrate this with respect to x. So what we have is f of x equals 3x 3 over 3 minus 5x plus c. So this can be said f of x equals x cubed minus 5x plus c. So what do we know? We know that f of 1 is equal to 0. Therefore, we can say that 0 equals 1 to the power of 3 minus 5 times 1 plus c. So 0 equals 1 minus 5 plus c. 0 equals negative 4 plus c, and c is equal to positive 4. So the equation that you're looking at is y equals x cubed minus 5x plus 4. And folks, that should get you your nice and simple achieved. Okay, so let's go to the next question. Question 3b. I'm not going to lie. I hate drawing. But you still have to learn how to do it. So in this case, you've been given the function of f dash of x, and you asked to find f of x. As usual, guys, some little shortcuts that I like to use. Now, for those of you that are there, it's like you can literally, with this question, you can come up with the equation of the parabola, and you can actually integrate it and actually get a really accurate answer if you want to. All right? But because we don't know the c value, it actually becomes quite tricky. But however, I'll show you guys this trick. I know that y dash equals x squared. When I integrate y dash, I get y. So that will become x cubed over 3. So in this particular question, I know I'm going to be drawing a cubic. That's for sure. And the best way to do it is look at where the gradient function is cutting 0. So those are the 2 points where the gradient is equal to 0, or turning point. Now, because it's a positive parabola and we're working with a positive cubic, the first one is going to be a maximum turning point and the second one is going to be a minimum turning point. So, and this maximum turning point, really, guys, it could be anywhere. It could be here, it could be there, and the minimum one could even, could be here, for all that matters. And that's all the information that I have. And from here, I have a cubic that's going to look, well, that's a turning point. Oh, that's a terrible graph. Let's try that again. Something like this. And that's going to basically get you the marks for it, because positive cubic shape will get you one part of the merit. Getting the turning points when x equals to 2 and x equals negative 4, which is those 2 things, will get you a merit, not an E, I'm sorry. That should get you a merit. But if you just have a positive cubic shape without the right turning points, you'll be looking at an achieved. All right, let's go to question 3C. 3C, we have Meg is riding a motocross bike. When she passes a fixed point on the track, she has speed velocity of 5 meters per second and an acceleration of 0.6. If she were to continue accelerate at this rate, what is the speed when she has been riding for 10 seconds after passing P? So let's have a look at what are all the things we know. We know that acceleration is equal to 0.6, which means when we integrate this, we're going to get velocity. Velocity is 0.6t plus c. But the one thing we know is that we're looking at the fixed point from the fixed point P. So we can say at point P, time is equal to 0 and velocity equals to 5. Okay, so that's what we're going to do and figure out what c is first. So when velocity is 5, when t is equal to 0, velocity is 5. So because we've got v equals 0.6t plus c, v equals to 5, 0.6 multiplied by 0 plus c. So we get 5 equals 0 plus c, and so c is equal to 5. What we have is the velocity function. The velocity function is 0.6t plus c. Now it says if she were to continue to accelerate at this rate, what is the speed when she's been riding after 10 seconds? So after 10 seconds, so we're basically saying when t equals to 10, what is the velocity? So v equals 0.6 multiplied by 10 plus c, oh no, not c, sorry, I forgot that. That should be 5 plus 5. And so velocity equals 6 plus 5. Velocity equals 11 meters per second. So to get this, you're already getting a merit. Antiderivative formula. So, sorry, I just read something in the marking schedule that was quite funny. Basically, this part here, getting to this part, is achieved. Now, in the answer schedule, this is the official answer schedule. It says obvious use of any physics formula without calculus not accepted. Okay, so for those of you that are doing physics out there, if you use your physics formulas here, it will not be accepted. Just thought I'd let you know. All right, let's go to question C2. So still working with that same question, but this time we're asked how far will she have traveled from P when she reaches a speed of 8 meters per second. So what do we know? We know that the velocity function is 0.6t plus 5. So what we're going to do is we're going to work out at what point is she actually, at what time how long does it actually take her to reach 8 meters per second? So we've got 8 equals 0.6t plus 5, and we've got 8 minus 5 equals to 3. Oh, forgot the 0. 8 minus 5 equals 0.6t. 3 equals 0.6t. And 3 divided by 0.6 equals to t. So t is equal to 5. Okay, so we've discovered that. But the thing is, we need to actually figure out what her distance is. Now, we know the distance is integral of velocity with respect to time. So then we can say s is equal to integral of 0.6t plus 5 dt. So displacement or distance in this case, 0.6t squared over 2 plus 5t plus c. Now, because we are saying when t is equal to 0, we said the velocity was 5, but that was previous question. We have to assume that the s is equal to 0 because we're trying to find how far she's traveled from P. So we can say that at P, t is equal to 0 and s equals to 0, which means our formula for s would then become 0.3t squared plus 5t. So we are trying to figure out how far she will have traveled from P when she reaches a speed of 8 meters per second. So we know that this happens when t equals to 5, and we're trying to figure out what s is. So we got s equals to 0.3t squared, so 5 squared, plus 5t, so 5 times 5, and this simplifies to 32.5 meters. So getting to the final answer, folks, find the distance traveled, is you're looking at an excellence. Finding the distance formula, I think just getting to the distance formula could get you a merit. But you also have to find and t. So you got to do both of these things to get a merit. Achieved is just this distance formula can get you an achieved. All right, so that was C2. Let's go to C3. Last question for this particular paper. Okay, so what we do know is Meg's friend Leo was riding with her, but he begins to decelerate when they reach a speed of 8. All right, so they both are riding with her. And from the previous question, we knew that when t was equal to 5, they reached 8 meters per second. When t was equal to 5, their velocity was 8. All right, so they've already traveled at first 5 seconds. And they also traveled 32.5 meters in that first 5 seconds. So that's all the things that you need to know. So at the 5th second, Leo starts to decelerate, which means his acceleration is negative 0.2 meters per second squared. Okay? Which means we can say that what we're going to do is we're going to put the point where he decelerates. So after that 5 seconds, he starts to decelerate. So at that point, we're going to say that's equal to 0, and his velocity is now 8. Okay? So this is kind of like looking at the time after the 5 seconds. We're going to see what happens after 5 seconds. So once we have this, we know that velocity is equal to integral of acceleration dt. So velocity equals negative 0.2t plus c. So at this point, we know that t is equal to 0 and velocity equals to 8. So 8 equals negative 0.2 multiplied by 0 plus c. So we can get 8 is equal to c, and we can say therefore velocity equals negative 0.2t plus 8. Okay, so that's the velocity function. Now for the distance, so we're trying to find how far past the point P they'll travel. So I still need to work out the distance formula, which is, I shouldn't use D, I should use S. S is integral of velocity with respect to t. But I want to actually figure out how much distance they travel after they decelerate. So which means I'm going to put t equals to 0 and S is also equal to 0. So this is 5 seconds after P. So I want you guys, let me just draw you guys a little diagram to show you what I've done. So this is point P. Hang on. So this is point P. They're going along, and then this is the point where Leo starts to decelerate. Okay? So it's almost like looking at it like two timelines. So from here to here, so this is 0 and 5 seconds for the first part. But for the deceleration part, what I'm saying is t equals to 0, and then whatever time goes along after that. All right? So integrating displacement, I've got S is equal to integral of negative 0.t2 plus 8 dt. So S is negative 0.2 t squared over 2 plus 8t plus c. Now, because t equals to 0 and S equals to 0, I can see that S is equal to negative 0.t0 squared over 2 plus 8 times 0 plus c. Should I put 0 equals to that? So from here, you can see that c is equal to 0, and therefore the distance formula is negative 0.2 divided by 2 is negative 0.1 t squared plus 8t. Still not finished though, because the question says how far past the point will he be when he reaches a speed of 6 meters per second. So obviously he's traveling at 6 meters per second. I need to work out what the time is, put it into the distance formula, and then calculate the total distance from point B. I might have to go to another slide, but I'll try and finish it in this particular slide, guys. So we've got velocity equals to 6, and we need to figure out what time is. Now, velocity function is v equals negative 2t plus 8. So 6 equals negative 0.2t plus 8. Negative 2 equals negative 0.2t. T equals negative 2 divided by negative 0.2, which is 10. So altogether, they've traveled 5 seconds first, and then they travel another 10 seconds. So I've got to find S of 10. So what's the distance after 10 seconds? Let's see if I can actually do it here. So S is equal to negative 0.1 t squared plus 8t. So S is equal to negative 0.1. T is 10, so 10 squared plus 8 times 10. And S is equal to 70. So this particular 70 is here. And from previously, they had 32.5, which was from here. So the total distance past P equals the 70 plus the 32.5, which equals 102.5 meters. Sorry guys, that's a really long question, but hey, that's just what we needed to do. So that's what's going to get you an excellence. For getting to a merit, let's see, you got to do two things. You got to find this thing first and the distance formula as well. So those two things you need for a merit. For achieved, I think somewhere here you can get an achieved. All right, guys, that's basically it for this exam paper. As usual, if you have any questions, pop it in the comments below. Any feedback is appreciated. And all I can say is good luck for your exams. In this particular paper, make sure, even if you don't know how to do something, it'll be either differentiation or integration. So just make sure you pick, you understand what the question's asking. And even if you just differentiate, you should still be able to get through with this paper. All right, so that's basically it for this session, guys. Thank you for watching and good luck for your exams this year.